SNS College of Technology, Department of Artificial Intelligence and Data Science, Principles of Operating Systems. Here, we are going to discuss in short the non-preemptive scheduling algorithms first come first serve, shortest job first, and the preemptive scheduling algorithms round robin and priority scheduling. Let us see the various scheduling algorithms. First one here is going to be the first come first serve scheduling, where the process execute in the order they arrive. And make sure like the order is the order in which the processes are being present in the ready queue. The first process here gets the CPU and runs until completion without any interruption. It is simple and easy to implement, but long processes can delay the shorter ones, causing a convoy effect and increased waiting time. Now it's a simple example here given based on the arrival time and the burst time. Like burst time is a time a process is going to use a CPU. You can see here the process P1 arrives at 0 time. That means it gets the CPU first. The burst time here is 4. After 4 milliseconds, the process P2 gets the CPU. It is going to have the burst time 2. And you have the process P3 arriving after P2 and the burst time of that is 5. So the total time taken to complete all the processes which are there in the ready queue is 12 millisecond. The next one here is the round robin algorithm. A round robin scheduling here states that each process gets equal time slices in the order it has to be processed from the ready queue. That means each process has a fixed time slice which we call here as a time quantum, and it is cyclic in order. If a process is not completed within its time slice, it is moved back of the queue and it will be present in the tail end of the queue. This method ensures fairness and good responsiveness, making it suitable for time sharing systems, though frequent context switching increases the overhead. And also you can see here long jobs take longer time to complete itself because of the time quantum. An example here quoted are the three processes P1, P2, P3 arriving at time 0, 1 and 2. The burst time for each of the processes being 5, 6 and 4. The time quantum given here is 2. That means each process is allowed only to use the CPU for 2 milliseconds. And once the time elapses, it has been moved to the tail end of the queue. And the total time taken for the processes to complete itself here is being put up as a typical example in the figure. The next important scheduling algorithm is the shortest job first. And this is going to determine that the process is being selected where the burst time of the processes is the shortest to one. So from the ready queue, based on the number of processes and their burst times, the processes are being scheduled. This approach minimizes the average waiting time and improves overall efficiency, but it requires accurate prediction of the burst time, and this may cause starvation for longer processes. Typical example here quoted are the three processes arriving at time 0, 1 and 2 with their burst time 8, 4 and 2. The processes are being scheduled based on their burst time, and you can see that the order of the processes are being as P3, P2 and P1 respectively. The next scheduling algorithm is the priority scheduling, where the processes with higher priority are executed first. That means on the ready queue, whatever processes are being waiting for CPU will be checked for their priority order and they will be scheduled based on their priority. Where the higher priority goes the CPU and takes the CPU, completes its task. And it is very useful for handling important or urgent tasks quickly. But remember, a low priority process may suffer starvation unless techniques like aging are used. Because The longer the time the processes are waiting in the queue implies that the process goes to starvation without even getting the CPU utilized for its completion. So in order to ensure that the priority is not going to disturb any process and not going to make a process to go to starvation, go with some other principles or techniques which ensures the fairness for the jobs to be processed. An example here quoted are the three processes P1, P2 and P3 with their priority being 2, 3 and 1, arrival time being 0, 2 and 1 and the burst time are 5, 3 and 6. And you can see here like the process P2 is scheduled first, then the P1 and then P3 based on the order or the priority that has been given here. And the scheduling algorithm determines the process moving from the ready queue to the CPU utilization. So far, we had seen how to evaluate and compare different CPU scheduling algorithms, the several scheduling criteria that are used, and these criteria measure how effectively the CPU is utilized and how well a system performance and user satisfactions are achieved. Thank you.